Hello, this is Mrs. Poland for Chapter 4 on Introduction to Experimental Design. You'll be recording some of the notes in this packet, so make sure you have your packet out to page 30. So some of the definitions that we examined today is an observational study. So that's when you observe outcomes, but you're not imposing any treatment, versus an experiment. And in an experiment, you're actively imposing some sort of treatment in order to observe the response that the treatment has. So I developed a new rabbit food, Hippity Hop. It makes fur soft and shiny. It increases energy. 100% of daily vitamins and essential oils. Hippity Hop rabbit food. Can I just make these claims? No. What must I do to make these claims? You have to do an experiment. What or who should I test this on? Bunny rabbits, of course. And what do I test? I'm testing the type of food. So that's the explanatory variable. So an experimental unit is the individual. It could be a person, animal, plant, etc., to which different types of treatments are assigned. A factor is another word for an explanatory variable. And a level is the specific value for the factor. A response variable is what is being measured, and the treatment is the specific experimental condition that's applied to the units. So I plan to test my new rabbit food. What are my experimental units? The rabbits. What is my factor? The type of food. What is my response variable? How well the rabbits grow, their energy, their coat of fur. And so here's Hippity Hop. I'm going to use my pet rabbit, Lucky. Here comes Lucky. He eats the food, and look at this. His coat is shiny, and he has more energy. Hippity Hop, therefore, is the better food. Can I make that claim? And the answer is no. I really need to use a control group to provide some sort of baseline for comparing the effects of the other treatment. It could be that, well, the bunny's lucky. Okay, he has a beautiful coat of fur and is full of energy to begin with. So a control group can be an inactive treatment, which is called a placebo. It could be an active treatment or no treatment at all. So my friend has a bunny, Flash. So I'm going to use both Lucky and Flash in the experiment. Lucky is going to get Hippity Hop food, and Flash is going to get the old food. Here goes. Here's Lucky. Here's Flash. There goes Lucky. Here goes Flash. Uh-oh. Looks like Lucky is bigger and shinier than ever before. So Hippity Hop is better. And can I make this claim? Absolutely not. Could be that, well, poor Flash is tiny to begin with. So how do we know if it's the old food or just Flash? So we need many, many bunnies. And so we have an assortment of bunnies, big and large. And I'm going to catch the bunnies. And the first 5 I'm catching are going to get hippity-hoppity food, and the remaining 5 are going to get the old food. So here goes. There's my 5 bunnies that I caught. Okay, they were big to catch. I was able to grab a hold of them. But the little ones were harder to catch, so they're getting the old food. Oh, what do I notice? Hippity Hop rabbits have scored higher, so it's the better food. Can I make that claim? No. There may be a reason why I was able to catch the other bunnies. They were bigger to begin with than the smaller bunnies. So there may be another reason why the bunnies who ate Hippity Hop food scored higher. So how do I resolve this? Well, I'm going to number the bunnies 1 to 10. So they're nice shiny coats and their numbers are easy to see. I'm then going to place the numbers on identical slips of paper and put them into the hat, and I am going to mix it very well, and then I'm going to pull out 5 papers. And the first 5 numbers that I pull out are going to get hippity hop food, and the remaining 5 are going to get the old food. So Bunny 9 got called, he's kind of small. Bunny 7 got a call, that's medium. 5 got called, that's big. 8 got called, that's medium size. And 3 got called, that was small. And the other 5 bunnies were pretty much the same size, and they got the old food. Okay, I evaluated the rabbits and found that the rabbits eating hippity hop food actually had better coats, were more energetic, and so overall it seemed like hippity hop the bunnies did better eating hippity hop. So the only way to establish any kind of cause and effect is with a well-designed, well-controlled experiment. You cannot establish cause and effect with an observational study. So what are the basic principles of experimental design? You have to have some sort of comparison. You need a design that compares at least 2 treatments. You need replication. So you need to use as many experimental units as possible in each group. This allows us to establish a trend. It allows us to distinguish the effects of the treatment as opposed to the effects of chance differences between the 2 groups. So if in that first slide with the experiment, when I had Lucky and Flash, the reason why that was not well designed is because you only saw 2 totally different types of bunnies, so you didn't know if it was the food versus the actual or the actual genetics of that bunny. You need randomization. You use chance to assign experimental units to the treatment. You could use a random number generator or a hat or a random number table. And the purpose of randomly assigning the bunnies into the groups is this creates roughly equivalent treatment groups by balancing out some of the unknown sources of variation, like the size of the bunny, the health of the bunny, and the overall type of the bunny. The other thing that you need is control. You need to make the conditions as similar as possible, like making sure that the bunnies are eating at the same time, that they are treated the same way, that their living conditions are the same, that they're drinking enough. So right now I'd like you to turn to page 30 in the packet, and we're going to go over some problems. At any time in the video, you can put it on hold so you can write down and record the answers. So 1A, does eating dinner with family improve students' academic performance? According to ABC News article, teens who eat with their families at least 5 times a week are more likely to get better grades in school. This finding was based on a sample survey conducted by researchers at Columbia University. So what was the explanatory variable? Whether teens eat with their family at least 5 times a week. What was the response variable? The GPA of the students. That's what was being measured. Was this an experimental study, or an observational study? Well, we didn't impose a treatment. We simply observed. Therefore, it's an observational study. Teens were not randomly assigned. That's the key. Were they randomly assigned into treatment groups? And they weren't. So therefore, you can only say it's an observational study. That doesn't mean you can't establish a pattern. You just can't establish a cause and effect relationship. So example 1B. In a diet study using 100 overweight volunteers, 50 volunteers were randomly assigned to receive weight loss counseling, monthly weigh-ins, and 3 months pass to the gym. The other volunteers were given a financial incentive $20 for losing 4 pounds in a month or paying $20 otherwise, along with counseling, weigh-ins, and gym pass. The group with the financial incentive lost 6.7 more pounds on average. So what was the explanatory variable? You got it. It's whether volunteers received financial incentive. What was being measured? What was the response variable? The weight loss. Was this an experiment or an observational study? Was the treatment imposed? Were people randomly assigned into groups? And they were, and therefore this was an experiment. Volunteers were randomly assigned into treatment groups, with one group receiving the financial incentive and the other no financial incentive. Example 2. So we're still on page 30. A farm product manufacturer wants to determine if the yield of a crop is different when the soil is treated with 3 different types of fertilizer. 15 similar plots of land are planted with the same type of seed but are fertilized differently. At the end of the growing season, the mean yield from the sample plots is compared. So what were the experimental unit? It's the plots of land. That's what the treatment was done on, the fertilizer. What were the factors? The type of fertilizer. How many levels? Well, there were 3 different types, so 3 different levels. What was the response variable? What was being measured? The crop yield. And how many treatments? Well, there's only one factor with 3 levels, so 3 treatments. Example 3, this is found on page 30, top of 31. A consumer group wants to test cake pans to see which works the best, and they're going to measure if it bakes evenly. It will test aluminum, glass, and plastic pans in both gas and electric ovens. So what are the experimental units? Well, the experimental units is the cake batter, because we're trying to see if it bakes evenly. What are the factors? Well, there are 2 factors, the type of pan and the type of oven. What are the levels? So the type of pan has 3 levels, aluminum, glass, and plastic, and the type of oven has 2 levels, electric and gas. What's being measured? How evenly the cake bakes. And what are the number of treatments? So to get the number of treatment groups that you have to set up, you take a look at each factor. One has 3, one has 2, and you multiply them together. So you actually need 6 treatments. So you could do aluminum electric oven, glass electric oven, plastic electric oven, aluminum gas oven, glass gas oven, and plastic gas oven. So that's a total of 6 treatments. But if you just multiply the levels together, that's an easy way of getting that answer. And then last problem, bottom of page 31. What are the effects of repeated exposure to advertisement message? The answer may depend on both the length of the ad and how long it is repeated. An experiment investigated this question using undergraduate students as subjects. A subject viewed a 40-minute television program that included ads for a digital camera. Some subjects saw 30-second commercials, others saw a 90-second version. The same commercial was shown 1, 3, and 5 times during the programming. After viewing, all the subjects answered questions about the recall of their ad and the intention to purchase the camera. So what are the experimental units? Well, those are the undergraduate students. What are the factors? There are actually 2 factors. One was the number of times the ad was repeated, and the other was the length of the ad. What were the levels? Well, the number of repetitions had 3 levels, 1, 3, or 5 times. And the length of the ad had 2 levels, either 30 seconds or 90 seconds. What was being measured? It was actually measuring a couple of things, and that's what you would normally do. They measured recall of the ad and the intention to purchase the camera. And what were the number of treatments? Again, just multiply the levels together. So you have 3 levels of repetition, 2 levels of add, so you would need a total of 6 treatments. I hope that this video was helpful, and I will see you tomorrow.